Hello guys, welcome back to SAM Trainers. In the previous video, we have seen forces and motion questions, how to solve forces and motion questions. Net force is equal to mass into acceleration, how to draw the diagram, how to analyze the system, whether you can analyze the system as a whole or separately, etc. So now today we will continue forces and motion and we will see the Pulley questions. So how to solve and analyze the Pulley questions. So this is our first question. Particles P and Q of masses 2m, 3m are attached to ends of a light inextensible string. The string passes over a smooth fixed pulley and masses hang with string taut. The system is released from rest. And we have to answer, write down equation of motion of for P, Q, acceleration, tension, force, distance, etc. etc. Okay, so what we will first do is we will draw a rough diagram. So the question is two particles of mass 2m and 3m are there. So basically you have something like this. There is a particle of mass 2m, that is P, and there is a particle of mass 3m, that is Q. That's it, nothing else is given. Okay, so now we will just see that particle Q has mass 3m. So obviously if the system is released from rest, it will go in this direction. So it will have acceleration like this and P will have acceleration upwards like this. What are the forces? The weight of P is 2 mg downwards. Weight of Q is 3 mg downwards. And there will be a tension T. And there will be a tension T here. So this is our diagram. So we will draw the forces, whatever we can, and we will just try to analyze the motion. Assume some acceleration. Okay, now let's see how to answer this question. First is, write down the equation of motion for P. So for P, as P is only moving in vertical direction, there is no horizontal direction motion and it is going upwards. So net force upwards in vertical direction. So what's the net force? Tension T minus 2 mg. And this net force will be equal to mass into acceleration. And this is for P. And similarly, we can write our equation for Q in vertical direction. In vertical direction, as Q is moving downwards, and we have assumed the acceleration to be downwards also. So net force downwards will be 3 mg minus T, because T is acting upwards. So in downward direction, it will be minus T. So this is my net force on Q. This will be equal to its mass into acceleration. So that's my A part. In B part, they are asking for acceleration of each mass. Obviously, we know they will be accelerating at the same, and we need to find the tension also. Okay, so this is my first equation. This is my second equation. As you can see, if you want to find the acceleration, we have to eliminate T. So what you can do is you can add them. So when you will add these two equations, so T minus 2 mg plus 3 mg minus T is equal to 2ma plus 3ma. Why are we adding? Because when you add, you can see that this tension will cancel. So on left side, we are left with mg, and right side we have 5ma. M can be cancelled. So A is coming out to be g over 5 meter per second square. So this is our acceleration. And this is same for both P and Q. But on P, acceleration is upwards, and for Q, acceleration is downwards, the direction. Next, they are asking is tension. Okay, so tension you can find from first equation or second. It's your wish. You can use any equation, it doesn't matter. So T minus 2 mg is equal to 2ma. So 2m into A. A is g over 5. So let's calculate tension. So tension will be 2 mg plus 2 mg over 5. So this is 10 plus 2 is 12. So 12 over 5 mg. So this will be our tension now. Okay, next is find the force exerted on pulley by the string. Okay, so this is our pulley by the string. So these are the strings. So this is, there will be a tension T like this. There will be a tension T like this. So total force exerted by these two strings will be 2T, right? So this will be 2 times T, as you can see in the diagram. So my answer is 24/5 mg newtons. Okay, next is find the distance traveled by Q in the first 4 seconds, assuming that P does not reach pulley, obviously. Now, Q is moving downwards and it starts from rest, right? System is initially at rest. So we can say for Q, what do we know? First, let's write initial velocity 0 because system is released from rest. Acceleration, we know it's downwards and its value is g/5. And time they have given is 4 seconds. And we need to find the displacement S. So what's the equation that connects S, U, A and T? That is S equals to UT plus half AT square. So this is how we will use this Suvat equation. So U is 0. So S will be half times acceleration is g/5 into time square, that is 4 square. After substituting the values, we will get this as approximately 15.68 meters. So that is the displacement by Q. Displacement by Q. Okay, next is, now if they ask what's the displacement by P, so obviously it will be same. So whatever distance Q will move downwards, P will move upwards. Anyways, next, state how you use the fact that pulley is smooth in your calculations. Okay, now if pulley is smooth, that's why we are able to take the tension in both the strings as same, as T only. So it means tension is same throughout. If pulley is not smooth, then this tension will not be same. So tension is same for P and Q. That is the string at P and the string that is connecting Q. So that's your answer. Okay, let's look at one more problem. So this is our second problem. So two particles of mass A and B, 0.4 kg and 8 kg, 0.8 kg respectively, connected by light inextensible string. Particle A moves on a horizontal plane 4.5 meter from a smooth pulley, which is fixed at the edge of the table. The string passes over the pulley and the B hangs freely with motion of particle this. The system is released from rest. Find the acceleration. Okay, so let's first draw a simple diagram. So we have a table. So let's say this is our table surface. There is a particle A. This is a smooth pulley. This is a particle B. Okay. And it's given that their masses are 0.4 kg and 0.8 kg. So mg is 0.4 g here and mg for B is 0.8 g downwards. There will be a tension here. There will be a tension here. Okay. Next is a frictional force of magnitude 0.08 g opposes the motion of A. Okay, so there is a friction force here that is 0.08 g. So that's our diagram now. Okay, let's see what they are asking now. A part, the acceleration of the system. So let's analyze both the particles separately. So if you analyze particle A, we can see that Obviously, if it moves, we actually don't know whether it will move or not. If it moves, it will move in the B will move in the downward direction, and A will move in the right direction. Obviously, and A can't move in the left direction, right? Let's see. Let's write the equation for A now. Now, A's acceleration we assume to be in right direction. So net force in horizontal direction for A is T minus 0.08 g is equal to mass is 0.04 into acceleration. Now similarly we can write for B in vertical direction, because B is moving only in vertical direction. So for B in vertical direction, and we assume that it is going downwards, so net force downwards is 0.8 g minus tension is equal to mass into acceleration. So these are the two equations. So again, if you want to find acceleration, you can just add them, because if you add them, you can see that T will get cancelled. So let's add them. So if you add them, you will get 0.8 g plus 0.08 g is equal to 0.84. This is 0.4, not 0.04. Okay. So this will be 1.2 times acceleration. So my acceleration from this is coming out to be this is minus. Okay. So acceleration is coming out to be 0.72 g divided by 1.2. So which is nothing but 0.6 g. So this is my acceleration of the system. Next is the time taken for B to reach the ground. Okay, so B is at a height of, it's given here somewhere, 0.5 meter above horizontal ground, as you can see in the diagram. Okay, so this height is basically, so this is my ground. So this height is 0.5 meters. Okay, so let's see now. So what's the displacement for particle B? S is 0.5. We know its acceleration is, we just calculated 0.6 z, and it initially starts from rest, so U is 0. So time we need to find out, time taken by B. So time we need to find out. So again, we will see which Subat equation connects SU and T, that is S equal to UT plus half AT square. So let's substitute the values. So S is 0.5 equal to half into acceleration is 0.6 g into t square. So from this, let's calculate the value of t. So t square is coming out to be 1 over 0.6 g, and time is coming out to be square root of this, so which is approximately 0.412 seconds. So that is our answer. So B will take this much time to travel downwards. That's it. That's all they are asking. So this is how you can solve these Pulley questions. So these Pulley questions are not that different from the earlier questions, which we analyzed two particles connected together in horizontal. So it's just that you have to assume that whenever this system will move, that is A and B will move, their acceleration will be same. And for A acceleration or forces, you have to consider in horizontal direction, and for B, you have to consider in vertical direction. So that's all. Thank you for watching.